Hello, good afternoon, and thank you for joining us in this Panta Rei Webinar number 4, ETP Equipment Maintenance. This is a very important webinar because you will have the chance to know how to take care of the main machines that are part of the effluent treatment plant. So thank you everyone for being here today, and Mr. Mirko D'Antoni will start this presentation today. Please, Mirko, you can proceed. Thank you.
Yes, hello and good morning to everyone. Thanks to joining us today. So this will be the first webinar in the Panta Rei series of webinars. Thanks for being here. Just a brief introduction about us for anyone who is not familiar with us. We are an Italian company focused on water and wastewater treatment for textile industries, and we are basically present all around the world. We are IR certified quality company, so we have quality standard certification, and this is one of our main goals, to provide the top quality products and technical solutions. We are part of ZDSC program, which has united partners and contributors with a common goal of guaranteeing water discharge with increasingly stringent parameters as a part of the compromise with environmental sustainability. And we are proud to be part of this organization. We have more than 90 working ETPs, and around 65 are located in the Southeast Asia, which is right now our main market. So now we are presenting the webinar schedule. So this one is the fourth one about equipment maintenance. Then next week we will have the webinar regarding the zero discharge of hazardous chemicals. After that, we'll talk about MBR, membrane bioreactors, then sludge treatment solution, and the last one will be about water and brine recovery system. Okay, let's start with the presentation. The aim of today's webinar is to give some knowledge and advices regarding the maintenance of the main equipment we have in the ETP. We're going to talk about fine screening, CONOSCREEN, dosing pumps, transfer pumps, and blowers. Here we have an example of fine screening installed in one of our ETP. So this one is the flow duration. You can see here the screen, the brush, and the collecting basket. In this slide, we can see more in details of the components of the screening, highlighted with the numbers in order to identify the spare parts. Fine screening is a simple equipment and doesn't need lots of maintenance. As you can see, we need to clean frequently the collecting basket, and take out the raw material. Every week, remove power supply of the screening and wash it with pressurized water. Every 2 months, check the condition of the brush and in case act on the springs to adjust the length of the brush, the distance between the screen and the brush. Then every 3 months, also we need to lubricate the bearings with the grease, and for gear motor use synthetic oil. Regarding the spare parts, we advise the required spare parts are the brushes, the shaft support, the gear motors, the anti-vibration system. Let's see now the CONOSCREEN. We have already discussed deeply regarding this equipment and how it works. In this simple sketch, you can see and we can identify all the components of the equipment and as well as the spare parts. Also, the maintenance of this equipment is not difficult. We need to check periodically the condition of the meshes and if are clogged or not, and if yes, we have to remove the raw material. Check the condition of the rubber disc gasket and of course also the nozzles. Every 3 months, the shaft bearing lubrication is required. Regarding spare parts, we suggest to have seals, filtering meshes, flange bearings, grease cartridge for bearings, washing nozzles, and rubber disc gasket. Okay, let's move to the dosing pumps. You can see in this picture some installation. This sketch identifies all the components inside the dosing pump. Especially in this sketch, it's possible to see the membrane, the gasket, the O-ring, the no-return valve. Okay, let me show to you one video regarding the maintenance of the mechanical membrane, the non-return valve. So first of all, we have to remove the power supply, okay? And then we can start removing the pipe from the suction and inlet section and delivery section. After that, we can remove the plastic cover and see inside the membrane. So to remove the membrane, we need to rotate it anti-clock, just manually, without using any tool. Then we can remove the O-ring, the gasket, and after that, clean the membrane chamber. After cleaning, we can install the gasket and the O-ring. After that, the new mechanical membrane, this time rotating it clockwise. Now we can install again the cover and tighten the screws and pay attention to the directions for the correct assembly. Now let's see how to replace the spare parts of the non-return valve in the delivery section and pay attention to the assembly scheme. So following the flow direction, we need to install first the O-ring, then the ball support, the ball, the plastic cover, and then the other O-ring. Just strictly follow this scheme. Also pay attention to the position of the ball support. That has to be in the right position. Otherwise, if it's not in the wrong way, then the liquid come back inside the pump after switching off. So this one is the wrong installation, while it has to be in this way. Now let's have a look to the main spare parts we need to keep in our ETP. So considering the delivery and the suction points, we need valve seats or rings, ball valve, mechanical diaphragm, and the valve guide. During the operation, of course, some issues could happen, and here you can find a list of the possible problems and corrective action that must be taken. In this table, a list of the operation to follow if the problem is the flow is lower than expected. So if we have the situation, we need to identify the possible cause, and from here, check the solution. While in this case, we have the solution if the problem is that the flow is irregular or higher than expected. While in this table, we can see the solution if the problem is the overheating of the pump or the motor. Okay, after those in pumps, let's see something about the transfer pumps. In this example, we have considered flight brand. This sketch is extremely important to identify immediately all the components of the pumps, as well as to check which spare part we need. And according to the sketch in the previous slide, you can find here a detailed list of the spare parts. So what about the maintenance? Has to be done every 6 months. And in this and the following tables, you can find all the action that you should take. So the expectation could be like check the cable, the power connection, the impeller, or the insulation, and the O-ring, and so on. Sometimes happens that the pumps has some problem, and to have a proper solution, we need to be sure about the cause of the issues. So if the pump doesn't start, could be for different reasons. And for each reason, we have the remedy. The same if the problem is that the pump doesn't stop when a level sensor is used. So most probably the problem is the level sensor itself. Another problem could be when the pump starts, stops, and starts in the rapid sequence. And probably the most common problem is when the pump runs, but motor protection trips. So just identify the problem, use the table to check the solution. But generally, when the protection trips, is due the wrong electrical connection, especially if it's delta instead of star connection. The last one is when the pump delivers too little or no water. So I saw often this situation during the ETP, and also here the problem could be wrong electrical connection, or sometimes also wrong pump installation. Okay, let's start with the blowers. We will spend 5 minutes more in this section. So this one is the robust group that consists of the expansion chamber, the bare axis, the filter, okay, the motor, and the transmission, so belts and pulleys. In this sketch, we can see very well and details all the components of the bare axis identified with a number in order to see the corresponding spare parts. So regarding the maintenance, the main maintenance for the blower are to check the lubrication, the filter, the shaft seal, and the belt drive. Regarding lubrication, okay, you can use this table to check which kind of operation you should be done, okay, and the frequency, where H1 is how many hours after the startup, while H is the total operation hours, then weeks and months, okay. Especially for the oil check level, okay, of course you have to see the oil level from the oil detector. Remember that when you drain the oil before to pour it again, you should take out the oil detector and clean it very well, because sometimes the oil can make a mark on the glass and you will never notice if the oil is inside or not. Regarding the filter, the maintenance is very easy. Every week, take out the filter and clean it with compressed air. In the front side of the blower, you can find this indicator where we have 3 zones: white, which is normal operation; yellow, which means alarm, you have to clean the filter; and red, that is time to replace the filter. Also, the shaft seal is an important procedure. It has to be carried out every 12 months. During the visual check of the condition, you need to remove the transmission, the wheel belt, and please remember, do not hammer the shaft or the pulley. Belt drive check is an easy operation, but extremely important. First of all, we need to be sure regarding the alignment, just using a yarn between 2 pulleys. And after the alignment, we have to play with the nuts, this one, to regulate the belt pressure, tension. Follow this frequency guideline to check the belt status and replace it after 16,000 hours of operation. Okay, now we can have a look to the troubleshooting. The most common issues you can have during the operation generally are overheating, vibration, oil leakage, friction defects, lubrication issues, and the no-retard valve breakage. So regarding overheating, the possible cause of overheating are poor ventilation in blower room, high differential pressure or low RPM, and safety valve wrong setting. We can identify an overheating if we are able to see that the paint of the blower body is burnt. So in this example is the overheating. So we have overheating due to the poor ventilation in blower room. Here is explaining how it should be the blower room to keep the robots cool. If we don't have this kind of configuration, then it's possible to have overheating due to poor ventilation. Why? What's happened when we have overheating due to the high differential pressure or low RPM? We can see in this image, for example, that from the delivery point, we have a thermal deformation. So it's possible to identify this kind of problem. You can see here, the paint is completely burned. In this other picture, we can see that in the suction point, the paint is okay. There is no problem. While here in the delivery, so which means here where we have the thermal deformation, the paint is burned. So regarding the speed, remember the importance of the minimum limits when using the inverter. If the frequency is low, which means lower than 40 Hz, the blower can suffer overheating as well as the motor. Another possible cause of overheating is the wrong setting of the safety valve, which is inside the Robox group on the back side. So if the safety valve is not tightened very well, from the delivery point, the air, part of the air, come back again inside the Robox group. This hot air enter from the suction point. So it will be a sort of recirculation of hot air inside the Robox group. While the main issues due to the vibration is the presence of dust inside the lobe, which of course affect the operation and could be identified. Why? Because the bad alignment between the blowers and the motor. This is why it is very important to use a yarn for the alignment of the pulleys, wear of the motor bearings, wear of the or breakage of blower bearings, and rotor loss of balance. Okay, why oil leakage? We can have oil leakage for different reasons. One of the most common is excessive oil level, especially during the startup, from the first time that we pour the oil inside. And then we can see that the oil comes out from the vent hole in the bottom of the axis. Also, the oil viscosity that is not suitable or high operating temperature, or due to the wear of the elastic segment or the relative spacer and the sealing chambers, and also dust inside the oil chamber. So in this picture, we can see the problem of the oil leakage, that in this case, you can see in these components, see this component is called oil labyrinth. In this example is clean, wow. But if dust come inside, or if the high temperature change the viscosity of the oil, we can have this situation. So instead the oil to fall off the labyrinth come out from the oil vent, from the vent hole. So how to solve this problem? We need to clean inside using the WG-40, and when spraying inside the vent hole, we need to rotate the pulleys. After that, we will see dark oil, like burned oil, coming out from this point. Okay, now let's see the friction defects. So we can have friction defects due to the impacts during transport or handling for blower with long storage time. So some oxidation in the compression chamber. The rotation is in the wrong way, is the opposite direction compared to the standard. In this case, the scratch on the heads of the lobes proves that the lobes are rotated in the wrong way. High temperature or difference pressure, high difference pressure, some solid impurities entering the compression chamber to the suction point, wrong radial or axial bends tolerance, and poor or wrong lubrication. So as you can see in this example, this one is a friction defect due to the radial. It's a radial defect. Well, this one is axial defect on the carter, on the front and back sides. And this one is due to the distribution. This one happens when the lobes, the alignment of the lobes, the tolerance is not the right one. Another example, you can see here the oxidation due to the long storage period or the friction. We have metallic material inside that scratch the surface of the lobe of the carter. And this one is a radial deformation due especially to the high temperature. Okay, now let's see the lubrication issues. First of all, we need to be sure about the type of oil, and we strongly suggest synthetic oil with viscosity 320, because otherwise if the viscosity is lower than if we have high temperature, then the oil inside change the viscosity and become, let's say, more liquid and go out from the oil vent. So that means the oil chamber will remain completely dry without any oil inside. So we have to avoid this kind of problem. In this example, you can see the deterioration of the oil due to the wrong lubrication. The plastic part are completely melt, also the bearings. And when you can see that the oil is black, it means overheating, low viscosity, or some impurity inside the chamber, like a dust. Okay, the last one is the non-return valve. It's easy to identify the breaking points, as you can see also here in this video. You can see here on the left side, we have this kind of breakage. So in this condition, we need to replace the non-return valve. So this kind of breakage happens due to the high temperature or back pressure, especially if we have a different blower in the same main pipeline. So thanks again for listening. So we can have a couple of minutes for some questions. So please use the chat box. Thanks again.
Thank you very much, Mirko. So as Mirko just said, please use the chat box for any questions and answers that you may have. And we just want to make an announcement. Actually, we will be postponing webinar number 5 because we are well aware that next week and in the upcoming days, there will be some very important festivities, very important holidays in Bangladesh, Pakistan, Indonesia, and also India. Therefore, after the Eid festivities, the Eid holidays, we will be doing the second series of the webinars. So this was the first series that concluded today with webinar number 4 about the ETP maintenance. And then the next webinars will be zero discharge for hazardous chemicals, will be MBR, and there will be also sludge treatment and zero liquid discharge. So please stay tuned in our webpage and also in the social media, as we will give you all the necessary information for the second series of webinars. So you will be able to find this presentation, this webinar, in our website, www.pantareiwater.com. If you go to the research and development section, you will be able to see all the webinar information. So Mirko, I think we have a question here. It's about the diffuser maintenance, about the diffusers getting some build-up on top. So how can we deal with this situation?
Yes, usually, so the diffuser can clog, especially in the process where we have extended aeration, so which means high quantity of biomass. And if you use the panel diffuser instead of the disc disc diffuser. Also, the material of the membrane is very important because, for example, if you have a simple membrane EPDM, this type of membrane is not anti-clog. While if the membrane, you have a special coating of Teflon coating, this kind of coating is anti-chlog. By the way, to clean the membrane, you can dose directly in the air pipeline formic acid or hypochlorite just for a couple of minutes, around 300 milliliter per diffusers, and clean it in this way.
Yes, and exactly as Mirko said, one of the most important things is the materials. The diffusers that we're proposing and that most of our customers are getting now have a Teflon coating on top. So this increases the lifetime of the diffuser itself because it avoids substances from clogging, from getting, let's say, stuck on the diffuser surface. So this is also very important. And we have one final question here, Mirko, regarding the clarifier maintenance, the scraping bridge maintenance.
Yes, for the scraping bridge, the maintenance is extremely easy. First of all, the main maintenance regard the motors, no? So it's the common maintenance for every motors. Just check the oil, change the oil after a certain hours of operation. And after the maintenance, I mean, if you drain the clarifier, you have to check the scraper condition, the wheels, and the scraping rubber.
Yes. Okay, so it seems that there are no more questions. So we will shortly be closing this webinar. Thank you everyone for being here today. As we said, this webinar will be made available in our webpage, www.pantareiwater.com. If you go and check the news and check the webinar section, you will be able to see not only this webinar, but also all the past webinars that we talked about the lockdown measures, what to do in the ETP, about the biological process, about also the pre-treatments that are recommended in order to save energy in the plant. So these are very important topics. You are free to go to our webpage and download these webinars and check these webinars. And thanks again for being here today. We hope to see you soon. Stay tuned because we will give you important information regarding the upcoming webinars in the social media and our webpage. Thank you, everyone. Thank you, Mirko. Thank you, Monica.
Thank you. Thank you, everyone.
See you
Thank
soon.
you. See you soon. Bye-bye.
Thank you. Bye.